As we have gone through so many cases of geometrical construction and so on and so forth, we also want to discover something that is related to what we have been talking so far. We have been discussing about diminished, we are talking about magnified, what real inverted magnified, real inverted same, what real inverted diminished, or virtual outright magnified. So the keyword like magnified, diminished is something to do with the linear magnification. So all this while we have been doing magnified and we have diminished. But generally, we can say that from this diagram we have U as an object distance and V as the image distance. So example will be this red object has a object height of HO, and then the image projected on the other side, which is real image, it has HI, which is height of the image. And we want to compare the size of the object, final object. When we say size, we actually mean the height. Size of image divided by size of object. We want to make a comparison. So when we make a comparison, we are actually doing some kind of ratio. You can look at this. This is a ratio of the image distance over the object distance. Okay. For example, if your U is 2 and your V is 8, so your linear magnification is 8 over 2. So it's 4 times larger. And do you notice that I put red dots here? Red dot, red dot, red dot. 5 red dots. And this will translate into next slide. Next slide, and you look at this one. These two are congruent triangle. Congruent triangles. Both sides. You realize that this U and HO, and then this V and HI, and because they are congruent, we can say that magnification is V over U, magnification is also HI over HO. So we can connect these two. V over U equals to HI over HO. This is the case of mathematics. They are the same angle, so they have the same mathematical relationship. Okay, revisit this page and you know what I mean. Okay, so basically when they mention size, they are not talking about the area or the volume, they are just talking about the height. Okay, they are talking about the height of the image. So these are the example, and a few points to remember is if the image is on the other side, it's always real. If you are here and then you get your image here, this object, this image, so this one is actually virtual. And virtual image or your V will be negative. And here your V image distance will be positive.